Hello and welcome to the Electrician's Hangout. Today's tutorial, we're going to get into the four-way switch. The last tutorial we did together, we took a look at wiring three-way switches. And hopefully the tutorial was helpful and you guys got something out of it that was useful that you could use in your next project for home improvement. So we're going to jump right in. What I did was I prepared a short screencast for you guys where I made a diagram to look at the way that these switches work a little bit more in depth. So what we're going to do is we're going to go ahead and jump into that, and then we're going to come back here to the board and we're going to check it out in real life. So let's do that.
Okay, let's get started here. What I have is a diagram showing a switch loop with two three-way switches and one four-way switch in the middle. The four-way switch is designed to operate with your three-way switches, and you can have as many four-way switches as you want in the switch loop. And keeping that in mind, you can pretty much control the light from an infinite number of locations. In the video tutorial on three-way switches, I got very in depth with the way that the contact positions work in each switch, to try to give you guys a better understanding of what's actually going on internally with each switch. And I will do the same in this particular tutorial, so that if you didn't look at the first one, you'll get the same understanding that I tried to get across in the first tutorial. And if you did look at the first one, you'll get a really quick refresher. So let's just go ahead and jump right in. What you want to do is visualize this as three different boxes that contain switches. The first box contains a three-way switch, which I aptly named three-way switch 1. The second box contains a four-way switch, which, of course, four-way. And the last box contains a switch that's the last three-way switch in the loop, which I call three-way 2. Okay. Each box is going to have two cables coming into it. Okay. The first box is going to have the supply conductor coming in. And when I say the supply conductor, what I mean by that is the cable. When I said conductor, when it's actually a cable, the cable that supplies power to your switch loop. That power can come from a circuit breaker panel. It could come from a outlet somewhere in your home. It can, wherever it comes from, the only prerequisite is that the power is continuously on or uninterrupted. You don't want to run power, say, from another switch or something like that, because in that particular situation, if you turn the switch off that's supplying the power, this particular loop would no longer operate. So when we say 110-volt supply, we want that to be uninterrupted supply, something that's not going to be turned off by something else, unless you have some type of trouble and the circuit breaker trips and it turns the whole circuit off. Okay, so each box has two cables coming in. The first box has the supply cable, which is a 2-conductor Romex. Leaving that box and going to the box that contains the four-way switch is a 3-conductor Romex cable. And leaving the box that has the four-way switch in it, we have a second 3-conductor cable that travels to or gets run to the last box, which has a 3-way switch in it. And in that box, we're going to have that cable that's coming from the box containing the four-way, and we're also going to have another 2-conductor Romex in that box that's going up to the light. And I guess we'll be able to see that a little better when we go down to our test board and watch the guy work. the white wire in each cable, when it enters a box, the white wire gets spliced. It just splices in every box. Uh, you don't want to have a situation, or you should never actually have a situation, especially in a residential uh, setting now, where your white wire, and the white wire is what's called the grounded conductor or your neutral. You should not have a situation where your grounded conductor or your neutral conductor is connected to your switch. That that's that situation should never happen, because the neutral conductor or the grounded conductor is a return path for your load. In this case, it's a light. So the electricity flows through the black wire to the light and returns back to earth through the grounded conductor or your white wire, commonly known as the neutral. So you would not see a situation where you have a neutral wire connected to your switch loop there. Uh, I'm going to throw a curveball, and it's not my intention to try to confuse anyone. When you have a single pole switch loop, you may see a white wire connected to that switch. In that particular situation, the white wire is not a grounded conductor or neutral. Is actually part of the switch loop. A lot of times, what end up happening is they'll run the supply wire up to the box that holds the light, and they'll run one cable down, a two conductor cable, to the actual switch. In that particular situation, because you just run a 2-wire cable down, all it has is a black and a white. So it's common practice, and it's also accepted by the code, that inside the light box where the wire originates from that you're running to your switch box, you are able to take that white wire and splice it to a energized conductor or black wire, in which case the white wire coming down to the switch is not a neutral, it's actually energized. And the black wire on the other side of that switch that goes back to your light becomes your switch leg, or the wire that turns the light on and off. But that's actually a topic for a whole nother discussion there, and I'm gonna try my best to try to stay on point here, because that's not what this tutorial is about. It's about wiring 3-way switches. But I just want to make it really clear that you should never have a situation where you have your neutral conductor or your grounded conductor connected to the actual switch. Not in a residential situation anyway. I mean, there are cases where you in some control circuits and control systems where you might have a neutral conductor that goes across contacts for overloads and things like that. But that's a whole nother subject. I gave a brief description of how contact positions work in the video tutorial for the 3-way switch. I'm going to go over that really quick, just so you guys can see what's happening inside the switch, which you will see when we go through the showing the path of the electricity. But real quick here, I'm going to jump at 3-way switch number 1. Imagine this black screw here being a pivot point for a contact. If I was to change the position of that contact, instead of it going this way, it would go straight across like so. So that contact position works by pivoting on this point and moving between these two screws. Okay? And it's the same with the other 3-way switch. The 4-way switch is very similar, but instead of it being one contact, you have 2 contacts. In this particular situation, you can look at this being a pivot point for this particular contact, and this being a pivot point for this particular contact. And what I'm going to do is I'm going to change the positions there really quick. And as you can see, this contact position moves from this screw to this screw, and this contact position moves from this screw to this screw. And that's how that guy works. So what we'll do real quick here is we'll just run through the path that the current takes with different switch positions and how it turns the light on and off. Right now, as we're looking at this, the light is actually on. If we were to follow the path of the current, which starts at the black wire from your supply here, remember I told you the white wires are returned, what you would end up seeing is this. The the current takes a path through the first switch there, and it moves through this switch that way, comes through this conductor here, goes down this way, up into the light, through the light and back through the white, back to ground. Alright, now we're going to change the position of another switch, and it really doesn't matter which switch position you change, the end result is going to be the same. So what we'll do is we'll change switch position for three-way number 2. Now what's happening is the current is traveling through this switch here, and it's going up that way through the red wire, but now it has nowhere to go, so the light's not going to come on. And we could go to any switch, it doesn't matter. We'll go to three-way switch number 1 and change the position there. Now what we have is the current traveling through this switch that way, back down, and the light comes on. And we could do this all day. What we'll do is we'll do it one more time, but this time we'll change the four-way switch position. So now what we have is the current travels this way, comes up, straight across, light is off. And that's pretty much how this particular switch loop works. It's complicated on the outside, but once you understand what's actually going on, it's actually not that bad. So what we're going to do is we're going to go to our test board where I've set up a loop there with 2 3-way switches and a 4-way, and we will take a quick look at that and show how all of that looks in the real world. So let's get into it.
Alright, now that we've got the screencast out of the way, we can jump into the actual physical real world here and see the switches in action. What I did this time around is I purposely threw in a metal box. In all the other screencasts that we've done together, I've used plastic boxes. And the reason I threw the metal box in is because when you're wiring a metal box, that box has to be grounded. I mean, I've went into a lot of jobs that someone did and they used a metal box and they failed to ground the box, and that's really not good, because if if one of the wires were to get skinned, or for whatever situation you had a wire that was energized come into contact with the box and it's not grounded, that box could become energized and it could actually carry current. So if you look inside the box, I have one of these screws screwed into the box. This is a 1032 screw. This one is green in color. The green color denotes that it's used for grounding purposes. And I have one inside this metal box here, and I have one of these bare wires connected to it. So now this box is effectively grounded. Also, with this particular type of box, the connector inside the box is actually designed to be used for either armored cable, MC cable, or Romex. If you notice, I'm using Romex. As you can see, I cut this part of the connector out. To keep the video short, I did it before I started recording because I didn't want to go over my time there. But basically all I had to do was take the connector out, clip this part out, and stick it back in. And as you can see, now it works perfectly fine for Romex. So it's a universal type connector. Alright, what else do we have? If you go back to the screencast and remember what we did there, like I told you guys, the wiring is pretty straightforward. Our supply, or our source, comes from the panel, and it runs straight across here, and it goes into the first box with a 3-way switch. we have a 3-conductor cable that leaves that box and comes to the box that contains our 4-way switch. And out of that box to the last box, which has our last 3-way in it, with a 2-conductor leaving that one and going up to the light. As you can see, like I showed you on the screencast, the neutrals splice through each box. What you didn't see on the screencast was the grounding conductor, this bare copper wire. That's your ground wire, or your grounding conductor. Not can be confused with the grounded conductor, which is the white wire, or neutral. Like I told you guys, it actually acts as a return path for your electricity, in which case that means that this wire actually carries current. So it's a very dangerous wire. Even though it's grounded, if you were to open it up, you have actual current on one side, the side that's not going back and being bonded to wherever your grounding source is. So be very careful that the white wire is a current conductor, the grounded conductor, the neutral, current carrying, which means that it carries current and it can hurt you. Okay, I think we covered most of how everything is wired on the screencast, and the only thing that's really left to do is to see everything work. First thing I'm going to do is I'm going to turn on the power source, the breaker, and like I say in every video, it's all about safety and being safe. I should have safety glasses on, and if you own a pad and you're doing home improvement around the house, any type of job, it's really a good idea to wear safety glasses. So, but anyways, you step away from the panel so that you're not standing in front of it. Put your hand on the breaker that you intend to turn on, and you turn your head and turn it on, like so. That way, if anything goes wrong, you're not standing in front of the panel to get injured in any kind of way. So now we have everything energized, and we could pick a switch, any switch, it really doesn't matter. Light should come on. Just imagine that each one of these boxes are in different locations in your home, and they're all controlling the one light. You now can control them from any location, like so. And that's pretty much how the 4-way switch works. It's designed to be put in between the 2 3-ways, and like I told you in the screencast, you can add as many 4-way switches, as many 4-way switches as you want, so long as they're placed in between the 3-ways. That pretty much concludes this tutorial. And like always, if you guys have any questions or you have any concerns that you need addressed, on Electricians Hangout site, there's a section for leaving comments. And you leave a comment and I will do my best to get back to you as soon as possible. So remember, be safe, wear your safety glasses, never turn a circuit on while you're standing directly in front of the panel. And that pretty much concludes this tutorial. Thanks for joining me, and I'll see you guys the next time. Bye-bye.